I'm Armin. I think you should know that by now. I don't know. Website scripting OS 10. New website since last year, macadmins.news for the weekly newsletter. Go subscribe if you haven't already. I also happen to work for Jamf as a consulting engineer. EMEA region, huge area. Great job. I don't like links and slides. I don't like QR codes either. This is the one link you're going to get. You're going to get it now and at the end again. So if you miss it now, you get it at the end again. All the notes, the slides, the video once it's up will be linked from this page. Patrick asks us fairly early if we want to come and what we would like to present. And usually, I think everyone puts in a placeholder and says, I need time to think. Yes, I'm coming. I need time to think. I knew this year Swift was going to be 10 years old, so I said, I'm going to do something about Swift. And I sent him this picture as a joke. And then a few months later, he's like, so seriously, what are you going to do? And I said, I'm so going for it. So today, this is Swift, the Eras Tour, my version. So why me? Why can I talk about this? What is my reputation? Well, I've talked about this before. 2018, I did a session on Swift. In 2021, during Mac Sysadmin Online, I did an insane 70-minute tutorial on how to build a Swift command line tool and a Swift app, which is still available. And in 2022, at the other conference, JNUC, I did a session on using Swift with the Jamf Pro API. I've also actually built tools. This is not just theory. We've put that into practice. In 2018, while we were still at Pro Warehouse, together with Arnold Nefkens and Misha van der Bent, we built a tool, Erase Install, which was a UI tool to, well, erase and install a Mac. Back then on Intel, it was way more complicated than going into settings. That is now defunct, doesn't exist anymore. Kind of sad. Another tool I started in 2017, command line tool, Desktopper, to set the desktop picture. Seemingly simple. I'm actually going to talk more about that later. And published earlier this year, it was in beta for forever. Setup Manager, an enrollment tool to show progress and coordinate what happens right after enrollment for Jamf Pro and Jamf School. Also a tool we built in Swift. On my weblog, you'll find a ton of articles that I've gathered over the years. Like how to run a shell command from Swift UI, the Chooser app I built in the 2021 presentation, several blog posts on how to properly package and notarize Swift command line tools and other more complex things that are more complicated than just an app bundle. The presentation on the Swift Jamf Pro API turned into a six-part blog post on the Jamf weblog, which is still there. And I just recently started one on Swift Argument Parser. And you'll see some of that later. What's my reputation for the other things? Well, I had to dig into my iTunes Music Store purchase history, which is actually still available within Apple Music. And I have the proof here that I purchased Taylor Swift's debut album in November 2006, which is less than a month after it was published. So very early fan here as well. That debut album, of course, had hits like Our Song, Should Have Said No, and Teardrops on My Guitar. Around the same time, November 2006, we got the Xserve with the moniker late 2006 with dual Xeon 5100 Woodcrest CPUs. Amazing. Came with everything that Xserves had. Among other things, it came with macOS 10 Server 10.4.8, which had hits such as Xgrid, iChat Server, Weblog Server, access control lists for the first time, and the software update server, and evergreens such as Workgroup Manager, file sharing with AFP and SMB, NetBoot, and Open Directory Server. Yeah, I can see we're all getting old here. The Xserve was the last Mac to get the Intel chip, finishing the Intel transition that Apple had started or introduced at the WWDC in 2005 and started with the MacBook Pro in January 2006. Less than 12 months, the entire Apple product line was switched from PowerPC to Intel. The Apple Silicon transition took a bit longer, but different times, different things. At 2006, Apple also had iPods. We're more interested in a bit more recent history, so let's fast forward to 2014. The Apple product line, very similar, the Mac Pro changed. Xserve, 2014, sadly gone. iPod, still hanging in there as the iPod Nano, but of course the iPhone and the iPad had joined the Apple product line and transformed Apple as the entire company. Operating system for Macs at that time was 10.9 Mavericks, and later in the year 10.10 Yosemite. And 10.10 Yosemite was introduced in October 2014, pretty much at the same time as Taylor Swift introduced her album 1989, bit of a confusing name here, which truly established her as a pop icon and superstar with hits such as Shake It Off, Blank Space, Bad Blood, Style, and Wildest Dreams. And even if the titles don't tell you anything, if you hear the songs, you will sing along. I promise that. Yosemite was introduced a bit earlier that year, in June at WWDC. Didn't have such great hits, to be honest. It introduced the flat interface that we had gotten in iOS 7, and still not a fan of it. Continuity, big fan of that. That lets you pick up what you did on your iPhone on the Mac or vice versa. The Today view in notifications. Photos got the iCloud photo library. And they introduced JavaScript for automation, or JXA. Actually talked about that last year. Not going to talk about that today. It was the first version of macOS 10 since the 10.0 public beta to get a public beta. So that was remarkable. And that public beta process now lives on in Appleseed for IT and the modern public beta and all of these things. Apple picked that up again in 10.10 10 years ago. We also got this.
Central to Xcode is the language we use to develop our apps, Objective-C. Now, Objective-C has served us so well for 20 years. We absolutely love it. But we had to ask ourselves the question, what would it be like if we had Objective-C without the baggage of C? Well, we did more than think about it. We have a new programming language. The language is called Swift, and it totally rules. Swift is fast, it is modern, it is designed for safety, and it enables a level of interactivity and development that you've never seen on the platform.
Thank you, Craig. So 2014 Developers Conference, quite surprisingly, as you can hear from the audience reaction, Apple introduced Swift. I think this is actually one of the great post-Steve Jobs moments in their keynote, mostly because of the surprise. They pointed out Swift would be fast, modern, safe, interactive. The stress here is definitely on safe, because that will be the theme since then, and it will also be a big theme today. They talked about some technical stuff that were introduced, and I'm not going to go into depth into those today. Watch the 2018 session if you want to learn more about those, because I talk about some of them. Otherwise, ask Joel. Joel's here. Some things have changed since the introduction. Very interesting developments. Swift is open source. Wasn't from the very beginning, but fairly soon they open sourced it. It works cross-platform. The compiler runs cross-platform on Linux and Windows, and the binaries you build can be cross-platform. Fairly new, we have an embedded Swift. Going to talk a bit more later. And you can compile Swift into WebAssembly, should you want to. So what are the errors of Swift? how did these last 10 years work? Of course, we got Swift 1 in 2014. Pretty rough start, to be honest. Next year, they introduced the open source project that goes along with Swift, which has grown immensely since then. And together with that, we got the Swift compiler for Linux and could compile binaries for Linux. Swift 3 introduced the Swift package manager, which allows me to build projects and share them over GitHub and similar sites so that I can include libraries from other people or from Apple or from other organizations in my code, and I don't have to reinvent everything all the time. Swift 4, remarkably, no marquee features. I did some research and I tried to remember, and like, yeah, no, really. It was basically a complete rewrite from the ground up. Everybody who had Swift code hated Swift 4 because you had to change your entire code again and again and again. You can see these first few years were really rough. Fast iteration is probably what you want to say. 2018, for the first time, no major version. We got 2 minor versions with some improvements. That's when I did my last talk. And in my last talk, I was already anticipating Swift 5 as the big change to come. And I wasn't pre-signed or anything. Swift 5 was in beta while I was doing the last talk, and it came in 2019. It brought with it ABI stability, advanced binary interface, which means that from then on, I could use more modern code with ODA libraries or the other way around, so I didn't have to jump on every new version and recompile my Swift code for every new version. So first era of Swift, the first 5 years, definitely volatile, definitely a bit rough if you were in it, but this changed with Swift 5. Because with Swift 5, we still got updates, 2 minor updates per year very regularly, in the spring update and then in the fall update on the Northern Hemisphere. But we still got changes. Swift 5 brought Swift UI. Apple introduced Swift UI, the user interface framework for Swift. Up until then, you had to use AppKit or UIKit. Now you got a native UI. And there's a reason Apple waited for Swift 5 to introduce this. The next year, we got compatibility with Windows, run Swift compiler on Windows, build binaries for Windows, and the Swift package index. The Swift package manager was successful. There were already hundreds of packages. So Swift package index is a database run by the Swift organization that indexes them. You can search for them. Very useful. And the remaining changes since then, and there were a lot, focused mostly on concurrency. All of the Apple devices now have multiple processors, at least 2, if not 8, 10, or even more. And you want your code to be able to work in parallel very well. And when you do that, you have to pay attention that they're not accessing the same data at the same time. One thread is deleting the data while the other one is trying to read it. That's what gets you crashes. And the improvements during the Swift 5 era usually were to improve this concurrency and data race safety. In 2023, last year, we got C++ interoperability. So Swift could always work with Objective-C and plain C code. Since last year, it can also work with C++ code. That's pretty cool. Swift introduced macros, which are super powerful. If you're used to C compiler macros, yeah, Swift macros are not like that. They are complicated, but they are super powerful. We got Swift data from Apple for Apple platforms, a front end for core data. And we can persist our data in a relational database using Swift data. And then this year, with Sequoia and iOS 18 and everything, we get Swift 6. So after 5 years, we get the next major update. The focus on Swift 6 is really even more on data race safety, concurrency. You don't want your code crashing when you have multiple threads accessing the same thing. It's also, for the first time, we get a cross-platform foundation library. I'll show that a bit later as well. We get a Swift testing library from Apple that works cross-platform. It works on Windows and Linux as well for unit testing our code. The point of Swift 6, and the Swift org is very emphatic about this, is not to switch as fast as you can. You can mix Swift 5 and Swift 6 code. You can mix Swift 5 libraries with Swift 6 code and vice versa. Everybody is aware that the switch will be slow, and that's okay. But if you start out with a new project, start out with the SwiftSticks, it probably won't be that great. So 10 years ago, Apple introduced Swift, said, wow, new great programming language. How is that going? How is Apple enjoying their own champagne? I found this website, timeact.org, and they put up statistics for the last few years. They analyzed the binaries that come with macOS and iOS. These are the numbers for macOS. I think it's more relevant here. On how many binaries or applications actually use Swift, and in this diagram, Swift UI. And you can see that after a bit slow start, the pace has been picking up, and a significant fraction has been built in Swift. These are Apple-provided binaries in macOS. If you look at the share, it's a bit more interesting, because now, if you look at Sonoma, we don't have the Sequoia numbers yet, about 1 in 7 of the binaries are built in Swift. Interestingly enough, the share is not taken away from Objective-C binaries. It is taken away from C and C++ binaries, which kind of makes sense because C and C++ aren't really known for writing safe code. It's a bit easier in Objective-C, and I think that's where Swift is mostly making inroads at Apple. Of course, we can only guess, but that's it. Swift is not just restricted to building for Apple platforms. I said it earlier, it runs on Linux and Windows. You can run Swift on the server. There are great frameworks for that. Vapor and Hummingbird are very popular. Of course, you can only really choose that if you start with a clean slate and want to start from scratch. But then using Swift on both the client and the server has the advantage that the data code can be shared. Makes some things easier. With Swift 6, we're getting embedded Swift, or a preview of embedded Swift. This is a smaller, lightweight form of Swift, and the library has a few less features, but that allows Swift to run on resource-constrained systems. One example, earlier this year, the Playdate project by the company Panic. It's a small handheld retro gaming device, very popular among some people. They opened up and you can build Swift games and apps for the Playdate. Kind of cute. More relevant for us, the Secure Enclave, that is on pretty much every Apple device, runs its own operating system, SecOS, and in that Secure OS, there is at least one binary written entirely in Swift. So even there, it is making inroads, and that uses the embedded Swift as well. But generally, if you want to build for the Apple platform, Developers Conference, all the examples are in Swift. Apple says this should be your starting point. Of course, if you have a rich environment, existing code base in Objective-C, you can keep using that. You can mix and match. You don't necessarily have to move everything over. But again, if you're starting from scratch, you want to use Swift. That's all well and good. This is interesting for developers. They care about these things. They build games for the Playdate and stuff like that. But we're Mac admins, right? We manage the Macs. Why should we care? And I was thinking about how I could make that obvious for you. And I think, an existing example, I said earlier, I've written a tool called Desktopper. And it's a command line tool. It sets the desktop. Yay. You can set the desktop with a configuration profile on macOS, but it locks it down. And many organizations don't like that. We want to set it for branding purposes, but the users want to personalize their Macs and change it. That's what I built Desktopper for, single-purpose tool. Yeah, I can demo that. It's not very complicated. However, Apple has done something in the last years, and they changed the UI, and it's not called Desktop Picture anymore. It's called Wallpaper. So the tool I'm going to build today is Wallpaper. And I'm going to do something that I haven't done in a long time. I thought, why should Joel have all the fun? I'm going to do this live. Silence, concentration. Thank you. I'm going to use Swift Package Manager. I mentioned that earlier. Swift Package Manager is a way of organizing Swift projects that works cross-platform. So I'm not necessarily dependent on Xcode. I could use any text editor. If you want, you can use VI. I'm going to use Swift Package Manager for that, because I like the command line tool, and B, because it has a template that gets me like 90% there. So I run Swift package, I create a new project, and I give it the type tool. And that will generate a bunch of files. I can look at those in the Finder. The package.swift, this is a so Swift thing to do. The package configuration file for the Swift package is not YAML or a plist or something else. It's a Swift file. It compiles as a Swift file. It's really strange, but that's how it works. Down here, I have the target. It picked up the name from the folder I created the project in, so it used wallpaper. It depends on argument parser, which is declared up here under dependencies. That's a project from Apple, open source, that allows me to build command line tools and parse the arguments that come in. I could do so manually, but there's a lot of things you could do wrong there, and using the Swift argument parser library is really a huge boon. This is the actual code. Of course, the template is hello world. Yay. I can run this. So everything is command line based. So I'm telling it to run the wallpaper target. And oh, wow. Oh, I'm not, I forgot that. I thought it would catch it, but I need my... Why
don't you try the password?
Yeah, right? No. I need my password. Thought I could get away without Wi-Fi. I stored it in here. Somebody said that would work, and it doesn't. So feedback for next year, make the Wi-Fi work better. Can I force this again? Yeah, the engineers in the room, does anyone know how to do this? Don't write it down. I need it for another hour or so. Okay, let's do this again. Swift run runtime. It downloads the Swift argument parser framework. It compiles it. The first compile takes a while because the Swift argument parser is actually really big. And then it runs my hello world. Yay, hello world. All that effort for hello world. I can also do a help. And this is actually really cool because the Swift argument parser framework picks up all the metadata it has about my command line tool and auto-generates a help. Now, there's not much in there yet because all it can do is print hello world and the help, but I didn't have to do anything for this. This is auto-generated. This is actually pretty cool. Let me close out of keychain here. And now I want to do more than hello world. So I'm going to open Xcode. And I said earlier, I don't need Xcode for Swift package. And that's true. If you want a different editor, you can do that. Xcode, however, has great auto-completion for Swift. And Xcode 16 actually uses some LLM auto-completion. And I don't want to type code in this demo. So I'm going to rely on that. So wallpaper, the first thing we want to do is if we run it without arguments, we want to print the current desktop picture, right? Macs can have more than one screen. So I have to loop through all the screens that are available. I really have to type this right. And it's screen.screens, auto-completion kicks in. This is wonderful. Oh no. Xcode always compiles your code and it pretty much immediately tells you, oh, that something's bad here. And this can be very annoying. In this case, however, it's actually a good warning. It says, I can't find any screen. What is this any screen you're talking about? Because it's a command line tool, it only includes the foundation, the non-UI part of the system. The screens part lives in AppKit. And the compiler here is smart. It says, did you want to import AppKit? Yeah, I did. Just click the button. It adds it up here. The error goes away. We're good for now. I want to get the wallpaper. Wow. Wallpaper. The autocompletion here is totally helpless, but as soon as I start typing it, I've done this so often, like I'm 5 letters in and it picks it up, it actually gives me the right thing. So the first thing is this the strange if-let construction. Swift has optionals. Greg talked about it 2 days ago. And they are really, really powerful, if somewhat annoying. And the if-let construct makes me sure that I don't do anything unless I actually get a valid value back. If you want to know details about optionals, ask Greg or Joel. So now that I know that I have a value, I can print it. And this is actually a URL object, which is a complex type, with all kinds of things. I'm only interested in the actual file path. So I loop over the screens, I get the wallpaper from the NS Workspace object, I print it. This should work. Let's try it. There we go. This is the path to my desktop. I have a very nice 10.4 Aqua picture here as my desktop. So that works. Well, that's the first step. We print the existing, but we want to do more. We want to read the argument, and if the user provides an argument, we want to read that. So first of all, we need some place to store the argument. I use a property wrapper that I get from Swift Argument Parser. Oh, the auto-completion is, there we go, path to the wallpaper. That's okay. And that extends this property with some functionality, and it basically fills it with data from the command line arguments. And I want this to be optional, and the way I denote an optional in Swift is with a question mark. So it can be nothing, and Swift Argument Parser will deal with that, or it can be something, and then it will fill it. So in here, in my loop, I can insert, well, if the path, very weird Swift syntax here, but just if it has a value, I can continue, and then I use NS Workspace again. NS Workspace, yes. Convert the path into a URL and set it for the current screen. I get an error. Oh, I mistyped here first. The first error, and then I still get an error here. The thing is, the NS Workspace function that I'm using, the library function, can throw an error. And I need to deal with that error, and Swift forces me to deal with that error. In this case, I acknowledge that the error can happen with a try flag, and because my run function is marked as it can throw errors, I'm just passing it up the chain, kind of ignoring it, passing it up the chain. This is actually useful. You probably want better error handling in your real code, but for the demo, that works. And then we have the else clause, so when the argument is unset, we do what we did before, we just print the path. So first thing is we test if we've broken everything. No, the first thing still works. And then I want to pass in an argument and change the picture. And my desktop picture changes. So we've rebuilt. But wait, there's more. We can also run this with the help flag again. And you can see that the automatic help generation of Swift Argument Parser has picked up my argument. It shows it properly in the Unix unit usage syntax with square brackets because it's optional. And it picked up the description I added in here in the help. So automatic help generation from my code. I don't have to worry about that. You could probably be a bit more verbose in your help, but that works. And there's one more thing that I can do. If I pass in an invalid file, then I get an error message that the file doesn't exist. And you're like, oh, where did that come from? I did not write that. I mentioned earlier that I'm taking the error that NS Workspace gives me and passing it up the chain. Further up the chain is the Swift Argument Parser framework. That catches the error, says, well, something went wrong. It pulls the error message that NS Workspace provides out, prints it, and exits with an error code. Automatic error handling. I didn't have to do it. I get that for free from the framework. So wallpaper, less than 10 minutes. We recreated Desktopper. Desktopper does a bit more. But the point of Wallpaper is we're using system frameworks to access pieces that would be quite hard to reach. Not impossible, but quite hard to reach with shell scripts. We use Swift Argument Parser to simplify the parsing and handling of command line tools. There's so much that Swift Argument Parser can help me with. It's a really powerful framework. Now, the real Desktopper, as I said, I wrote this a while back because it was annoying to manage the desktop in a non-prescriptive way. Usually, you would take the Desktopper binary and then add an image file, create a script that uses Desktopper to set the image file, probably a launch agent to run it at login or when the thing gets installed. You would put all of that in a custom package. Since Ventura, we need to approve the launch agent, so we need a configuration profile to approve the launch agent so that the user doesn't just turn it off either. All of this, it was tedious. I mean, I built Desktopper to simplify things, but it was still tedious. So, oh yeah, I have to sign the script so I can run it from an approved launch agent. I need to sign the script. Signing scripts, possible, painful. And every time the image updated, I had to update the image and the script and re-sign the script and build a new package and deploy that. Horrible. So earlier this year, or sometime last year, I looked at it and said, I can do better. The first thing that I did is I looked at the script and I said, I can put the functionality of that script into Desktopper, but I need to find a way to get which image do you want to set into Desktopper. And when I'm managing through a management system, I can't use command line arguments. So I put it in a custom payload in the configuration profile. We already need a configuration profile for the launch agent. Might as well add a custom payload for the image file path. Because Desktopper is already signed, signing binaries, really easy, I can do away with the script. First simplification. Then I looked at the image and said, well, I could teach Desktopper to download the image from the web, and instead of giving it a file path, I give it an image URL in the configuration profile. Next simplification. I only have the binary and the launch agent in the package, much simpler, doesn't update very often, if at all. And any changes I do happen in the configuration profile. Just need to update the configuration profile. It will update the desktop picture on all the clients if you want to. There's a bit more to it, but that's basically what I did with Desktopper. This is the main thing. All the security requirements that we now have in macOS require some form of signing and notarization, messing with certificates, dealing with privacy preferences, policy control, PPPC, entitlements, background approvals, all of these things. They are hugely painful with shell scripts. They're still kind of painful with native binaries, but much easier to handle. One example is Bart Reardon's Swift Outset. Outset used to be a Python library, Python tool. Swift Outset, Bart Reardon rewrote it a few years ago in Swift. One login item to rule them all, needs a ton of entitlements and PPPC and background item approvals. The project is signed and notarized by the MacAdmin's open source certificate, so that's a great use of this, and it is much easier to manage this. You deploy the app bundle, give it the necessary entitlements, and it just works. There's a ton of work with preferences, profiles, and app config. If you want to configure your things, we could edit shell scripts, as with the dep notify script, or we can use configuration profiles. So for example, Setup Manager, you don't have to edit a shell script. It reads all of its configurations out of a configuration profile, which is a bit easier to manage than editing shell scripts. My coworker, Aaron Maxim, consulting engineer in the US, wrote a tool to leverage the new return to service functionality on iOS and iPadOS, and that is configured with app-config. And the amazing thing is, whether you use app-config, configuration profiles, or local preferences, the framework in macOS and iOS to get to those is exactly the same, and it's really, really relatively simple. As MacAdmins, we often need to create custom profiles. Those are complex property lists with dictionaries and arrays. There are great tools to do this. First-time sponsor this year, iMazing, is providing a tool, iMazing Profile Editor, for free to the community. It's written in Swift. Creates custom configuration profiles. Nindy Gill has a tool called Low Profile, which allows you to inspect the profiles installed on the system by the MDM, written in Swift. I have a command line tool. I like command line tools, called plist to profile, which takes a local defaults plist and converts it into a custom profile. And then there's, of course, the PPPC utility that we've been providing from Jamf for a while. Having native tools also allows us to plug into security-sensitive things in macOS and iOS. Case in point, the authentication workflow. Of course, Xcreds by Tucanu and our own Jamf Connect plug into that and replace the login workflow if necessary. There's another tool by Elliot Jordan from Netflix called Escrow Buddy. It also plugs into the authentication workflow. And it doesn't replace the authentication workflow, but it checks if the file vault recovery key, wherever you escrow it in your management server, is still valid. And if not, it has the password because it's part of the authentication workflow and can update the escrow file vault recovery key without prompting the user again, because it keeps it from that moment where they logged in. Very smart tool. I really like deploying it. All of these are written in Swift. There are also system extensions where macOS and iOS allow us to plug into certain workflows. Endpoint security, of course, allows me to log or inspect or even prevent app launches or file access and many other things. And then there's the network extensions for VPNs, relays, firewalls, filters, all of these things. And just as an example, I might be biased here, but Jamf Protect and Jamf Trust from Jamf are extensions that use these frameworks, and they're written fully in Swift. So I'm not saying this that Swift makes everything wonderfully better. The programming language you use usually shouldn't matter how good a tool is. That really depends on how you write it. But you might hear that it's not possible to build complex, big solutions in Swift, and that's simply not true anymore. There's many, many more. I'm really sorry if your favorite tool was not on my list. I have a much longer list that I'll have to see what I work on. But I'm running short of time already. I talked about the Objective-C Cocoa Bridge already. So when Apple introduced Swift 10 years ago, they didn't want to rewrite all of macOS in Swift at day one. They couldn't possibly. So they gave us something called the Objective-C Bridge, or C Bridge, that allows Swift code to access the existing frameworks, which are written mostly in C or Objective-C, and allows access and use them in Swift. And that worked pretty great most of the time. The thing is, though, over the last 10 years, Swift has gotten this native foundation, direct access to the system, written directly in Swift. And they had to do that because the goal was to eventually, with Swift 6, have a fully functional Swift foundation that runs cross-platform on Linux and Windows. And Linux and Windows don't have Cocoa and Core Foundation and all of these things. So that's a great progress. We can stay fully native in Swift, make our tools more portable if the need be. But on the other hand, if we stay on Apple platforms, we have the best of both worlds. We can still pick features out of Objective-C and C that might be Apple-specific, but also use the Swift Foundation that is a bit more Swifty and a bit more modern and safer and all of these things. The Swift Package Index, as I said, provides tons of native libraries, Swift functionality that I can extend. Apple introduced Swift testing, a unit testing framework, just this year for unit testing your code. Also works cross-platform. Some things in Swift are, of course, restricted to Apple platforms. Just by the nature of things, Swift UI will only run on Apple platforms, but it will run on all Apple platforms, from the Watch to the Vision OS. Swift Data is another one that is only restricted to Apple platforms. The interesting one for us is Swift UI. It's a user interface UI that is Swift native in Swift style. It uses declarative syntax, is state-driven, and integrated with Xcode. Okay, what does that all Declarative syntax means that every piece in my UI has a declaration in code that represents it. It's pretty much like writing an HTML page where I do the header and then the body and everything. Here I have an image that is represented by an icon and a hello world text that is represented by the text. State-driven means that the data that I'm working on in my code is represented in state variables. And these state variables are connected to the UI elements through something called combine. And as far as I'm concerned, that's magic. That means that I can have a two-way connection. In this case, my state variable, the verb, has a two-way connection to the text field. That means if somebody updates the data in the text field, my variable updates. If something in code updates the variable, my text field updates. But I can also use that like any other Swift variable. And in this case, I have a calculated property that uses that to generate the verse line. And I'm using the verse line in a different UI element. And everything just magically updates when I click on it and move on it. And I don't have to bother about these things. If you ever build AppKit stuff, there's a lot of glue code you have to write for this. And in Swift UI, that just happens magically. So I can show you a nice, funny movie, or we can do it live. So let's build a UI version of our wallpaper app. I'm going in, and I want a new project. I'm in macOS. I want to build an app. I want to give it a name. It is in Swift UI, so that is fine. Need a place to save the project to. Now, I really tried to have this no cheating, nothing like I prepared this earlier, but I realized that no matter what I do, there would be quite a bit of typing involved. So to save the typing, I prepared something earlier. I will show what I'm doing here. The first function in here opens a file picker, the standard macOS file picker. And when I open a file picker in macOS, I need to configure it, like give it a message and everything, and configure what files I want to show. So I only want to show image files. And then in the end, I run it, and if the user hits cancel, I return nil, and if I get a file back, I return that. This is a lot of typing. Didn't want to do that on stage. The second function I have in here is I'm extending a system object. I'm extending a Swift UI object because this one returns an optional URL, and the built-in image object in Swift UI doesn't know how to deal with optional URLs to display them, which I found annoying. So I extended that so I didn't have to type it later in the demo. That's all that I cheated on here. This is our template, again, hello world. I can see that I have an image object here that is represented by the icon, and I have a text object that is represented here. So I can update the text, and it updates it live. I can also go in here. Xcode provides me a UI way, so I don't have to remember all the parameters and everything all the time. It automatically updates the code, and the code updates the UI. I can go in here and make the icon larger. It's a bit weird. It uses SF symbols for the icons, which are really powerful and awesome, but they actually behave more like fonts. So to make the icon larger, I have to give it a larger font size. A bit of an oddity in the SF symbols framework, but basically that's how it works. And if I don't like the color, I can also go in here and make it green. So this is a very interactive way of coding. Even if you don't know all the commands, it's easy to use the UI to update things, and you get immediate feedback. So this is nice. We could play with this for a while, but I'd rather build our wallpaper app. So I will go in here and delete this image, and I want to display the current desktop. So I created this earlier. I want to put my state in here, and then I get an error because I don't have the state variable yet. So I want to create my variable state var wallpaper, and the autocompletion is not dumb here, but I don't want to initialize it with nil. I want to initialize it with the NS workspace. And this is not what I want, but this is. I'm cheating a bit here. I'm ignoring that there could be multiple screens, and I'm just, wow, using the first screen, the main screen. I will leave that as an exercise for the attentive watcher to extend this to multiple screens. And then my preview updates, and I already see, oh yeah, great. I see the image, but the scale is all wrong. So I go into the UI, add the frame. That should make it smaller. I change how it stretches the image. I like that much better. Still, we can make this look a bit better. I add a clip shape. Circle is fun, but I'd rather have a rounded rectangle with a corner radius of 12 and give it a shadow. So I can run this. The preview looks nice. I can run this. This gives me a full-blown app. I have a menu. I have window management. I can resize the windows. Everything is fine here. I can move around. I can actually even create multiple windows. Probably should work on that. But I have my UI. Everything works fine. Now we want to add the interaction. So we want to set the desktop picture as well. I add a button. Set wallpaper. And when I click the button, I want it to do an action. So we have prepared that. I want the new wallpaper. I get that from my file picker. So I have the auto-completion here. I set that to the existing one as default. If I get something back from that, I want to update the existing variable and also use NS Workspace to set the desktop image. I get one error here because I need the exclamation mark at main, but even when I fix that, I get a second error, and if you paid attention, you will notice that I did the same error as before. NS Workspace, setting the desktop, throws an error. I need to mark that, but when I mark that, I get another error in a different location in the code. And if you try to read that error, this is absolutely obscure. What's happening here is the code block that the button gets is not supposed to throw. The button does not know what to do with an exception that gets thrown here, and that's what it's complaining about, even though the error message doesn't look like it. And even though I'm getting the error message up here, the way to fix it is down here by adding the question mark to the try, which tells it, just ignore any errors that get thrown. Probably not the best way to handle errors, but we're doing it for the demo. And then the error message goes away. This happens a lot in Swift UI and Swift, that you get an error message in one part of the code that you need to fix elsewhere. And they've made a ton of improvements to the compiler and Swift UI over the years to make this better, but it's still very frustrating. I mean, these are 6 lines of code, and it's already confusing. Imagine you have 100 lines of code, and then it's just not fun. But now we compile this, we see our button down here, and I set the wallpaper, and I can select a different image, and my UI updates, and my desktop picture updates. So, wallpaper UI. We can use Swift to build, whether you use Swift UI or AppKit or UIKit, you can build rich user interfaces. Managed Software Center in Monkey was converted a few years ago already into AppKit. And Greg talked earlier about it, on how he's converting all of Monkey into Swift. On the other conference in Nashville this week, Jamf introduced a replacement for the self-service app. We're calling it Self-Service Plus because it has way more features. It's a complete rewrite from the ground up in Swift and Swift UI. It's actually really cool. You won't see this, but yeah, I saw some of the code. It's really cool. Bart Reardon also wrote Swift Dialog. And I love Swift Dialog. There are so many tools that use Swift Dialog. You can just pop up dialogues, as the name says, from shellcode to get some user interface in shellcode. And I use it. It's great for prototyping or a quick proof of concept or just a quick script to fix something. I have one beef with it, though, and this is not Bart Reardon's fault. I don't want to put shade on the great work he is doing. But if you use Swift Dialog, your UI will look like the same as every other UI. And you will be limited the same way as every other UI. And it's great for a quick fix or a quick prototype, but when you reach the limits, maybe think about, oh, can I just write a quick Swift UI app like Apple did on stage, like Armin did on stage, and have my own UI and my own customization and make it look exactly the way I want? I think that's great. That's what we did. We looked at Deb Notify and all the great tools that are there with Swift Dialog that do the progress right after enrollment, and we built Setup Manager because the configuration and the scripting was just too complicated, and we also wanted it to look better. And we can already do some things because it's a native app that were difficult before, and we have some more things planned that will be possible because it's a native app. So I've been cheerleading now for nearly an hour. Are there downsides? And yes, there are. First of all, it's still evolving. It's not evolving as fast as the first 5 years, thank goodness, but it's still changing. Apple is putting all of their effort for innovations into Swift rather than Objective-C, and if you like that stability, then maybe stick with Objective-C. But we're getting the new stuff in Swift or in Swift first, but that also takes effort to keep up with. Also, macOS and iOS and all the other platforms, Apple is continually updating them, and if you're writing native code, you have to keep up more with those than when you're doing shell scripting. And then it is a complex language and a complex environment. And you will start in the beginning and say, oh, this is complicated, I can deal with this. And then even more comes in. You will have to deal with concurrency and optionals, ask Greg, and Swift data and testing. And Xcode is a very complex IDE, powerful but complex. You have to choose whether you use Swift UI, AppKit, or Catalyst. I'm not saying this to scare you away. I'm telling you that if you start down this road, you will get into this mode of complete confusion and being overwhelmed, and that's normal. Tackle it, every small problem at a time, and you will work your way through it. It doesn't matter, actually, if you use Swift or another language. All of these things will be decisions you have to make. There are great tutorials to help you. These are two that I found very helpful. Apple has a shortish tutorial. They say it takes 4.5 hours on their developer page called Introducing Swift UI. There's actually a small section in there that is for macOS, which is very special. The other one is from Paul Hudson on his Hacking with Swift website. It's 100 Days of Swift UI. It gets updated every year with the new stuff. It's meant as a course, every day 1 hour for 100 days. It assumes you know programming, but it doesn't assume you already know Swift. The first 20 days are just Swift, and then it goes into Swift UI projects. I'm on day 60-something, never finished it myself, to be honest, but it lays a really great foundation. This is for iOS only, but it gives you a good foundation, and you can transfer much of what you learn to macOS. Now it's red. Paul Hudson also has a dedicated class for hacking with macOS that is not free. The 100 Days of Swift UI are free. The hacking with macOS is not, but well worth the money. There is a great tool by Sarah Reichelt called macOS by Tutorials. I've read the first edition. It's written for iOS developers who are moving to macOS, and it shows lots of different things that are special about macOS, because no matter what Apple says, the platforms are very different. Just recently, the second edition came out. Haven't looked at that yet. Ooh, Patrick is looming. So, Swift and Swift UI. As I've said before, it is one choice among languages. I still believe Bash should be, or shell scripting should be, the first choice for Mac admins. But You will run into the limitations of that very quickly, and I think Swift is a great step up. There are other choices. You can write in Objective-C, Python, Go, Rust. These are all great languages. Tools written in these languages aren't necessarily worse. They also aren't necessarily better. The environment that you're working in, the goal that you're working towards, will pretty much dictate which tool you use. But if you're on a clean slate as a Mac admin starting out and saying, I want to build somewhat more complex tools, give Swift a try. Thank you very much.